This is Josh White with JW Math Tutoring. In today's video, I'm going to go through more advanced use cases of regression, including how to find two solutions when solving an equation using regression, and also how to factor. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Welcome back to another part of my Ultimate Desmos Guide to Digital SAT Math. This video is going to cover some new tips and tricks in Desmos that I've learned recently, and it's going to focus primarily on factoring or finding factors, but there's also a little thing related to using regression to solve equations in terms of returning more than one answer at a time that I'm going to go over as well. Now, just a couple things before I get started going through these. First, the guide itself, which is what you see on the left side of the screen right now. There'll be a link to that in the description of the video and also in the pinned comment of the video. The problems that I'm going to go through, the example problems, I think there's 7 in total. I can't remember, it's 7 or 8. Those are going to be linked as well. There'll be a PDF to the entire group of problems, meaning all the problems way back, from the beginning. And then there'll also be a link to a PDF file with just the new problems covered in this specific video. So either look in the description of the video or look in the pinned comment of the video to get those. I also have the web version of Desmos up, specifically the College Board version. That's what I've got, up here on the right side of the screen. So I'm going to be doing these problems in there. Of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Otherwise, we can go ahead and get started. All right, so the first topic I want to go through and talk about is basically how you can get Desmos to return more than one answer when you're solving an equation using regression. And that's basically the idea. Because normally, when I've showed you how to solve a single equation previously, you would type left side tilde the right side. You change the x's to x1, or if it has a different letter in it, you just keep that letter in it. And it'll give you basically one answer, one solution. However, sometimes an equation will have 2 or more solutions, and you want those 2 or more solutions all at the same time. So what we can do is basically the following. You're going to take the equation and essentially rewrite it so that everything is on one side equal to 0. And you're going to type that in as a function. So you're going to type in f of x equals, essentially the left side minus the right side. And then in the next line, you're going to type in really what's a system of equations. And essentially, in this case, x1 and x2 are going to represent my 2 solutions. And you're going to tell Desmos that both of them are equal to 0. And then the key is you're going to put in this constraint where you make one of them larger than the other. So for example, x2 greater than x1. That's going to force it, hopefully, to find 2 different answers or 2 different solutions. Okay? And again, this is useful because sometimes you might, if you solve an equation using regression, and it gives you an answer, but that's not the answer you're looking for, you might not know what direction to go to look for the other answer. Like, do I need to go look larger or look smaller? And it's, again, useful for determining, say, a positive solution versus a negative solution as well. Now, I have had some issues where when one of the solutions is equal to 0, this constraint doesn't quite work properly, and like even when I put it in, it'll then end up returning, they'll return 2 different values, but they'll both be infinitesimally small values, where Desmos is still treating them both as 0, even though technically they are both not 0, and one is still larger than the other. So that's just one, basically one thing to be aware of. I have run into occasional issues trying to use this where that has happened. All right, so let's go ahead now and take a look at some example problems. So at the top here, the first one, let me actually zoom in, make this a little bit larger. Okay, so the first problem here, I have an equation. It's a quadratic equation, and it wants to know, we want to know what is the sum of these two solutions. Okay, now of course you could distribute out the left side, combine everything, on the left side equal to 0, and then you could do the shortcut of negative b over a, like that's perfectly fine, but this is just showing you an alternate way that you could solve this in Desmos. So what I'm going to do is I'm going to type a function. Again, I'm going to do left side minus right side. And for this function, of course, I don't need the x1s. Okay, so now inside here, I'm just putting the entire right side. Okay, now is where I type in basically the system of equations. So x1 and x2 represent my two solutions. And they are both going to be equal to 0. Notice what's happening here is just before I put the constraint in, they're both the same. It's both finding the same answer. If I zoom out on the graph, they're both finding this solution, this x-intercept right here. They're not finding this other one. So now, notice when I do that and I force x2 to be greater than x1, then it finds the other solution. So, okay, now what's the sum of these two solutions? Well, it's 18. All right, and that's our answer. So again, this is just showing you how you can get two answers when you're solving an equation using Desmos. Now, let's look at the next one, 67. So this one basically is the exact same problem. Notice the exact same equation. So everything basically essentially is the same. It's just now you have, it's asking for the product of them. So you just take x1, multiply it by x2, and notice now I get 7. Okay, so the product of these two solutions is 7, and that's it. And notice it's carrying along the exact values for x1 and x2. You know what I mean? Even though it's only showing so many decimal places here, it's pulling through the full exact value, which is what makes this useful. Because regression will give you the exact values as compared to, say, like just taking the x-intercept values from the graph. All right, so this is not an example problem, but I do want to see, just want to see if I can get this to come up, to get this issue to occur, just to show you what I'm talking about with the issue with zeros. So I am going to type in a new equation here. Let me see if I can do this correctly. You might recognize this. I don't want to specify exactly where it's from just to not spoil it for anyone, but so the left side of this equation is the 2x squared plus 720x. The right side is what I am typing now. So sorry, just give me 1 second here just to make sure I get this typed correctly. Okay, so here we have an equation. I've done left side minus right side. Okay, and if you see on the graph, well, you can clearly see here there's two solutions. It's 0 and 8. That's, so that's what we would expect. So notice without the constraint, okay, it just returns both of the ones as 0. Okay? So what happens if I try this? So notice what happens is it still so it makes x1 0, which that is valid. However, notice for x2, it's a ridiculously small number. It's times 10 to the negative 168th power. So it's technically greater than 0, but for calculation purposes, its Desmos still treats it as 0 when it goes to plug it in the expression. So you can see that basically there's an error here. There's a disconnect. It's not quite working appropriately. So let me see here. Sometimes you might have to add a second constraint Notice here I add a second constraint for x2, which forces it to be forces it to be not only greater than x1 but also greater than 0. And those two together now force it to narrow down and find the right solutions, which are 0 and 8. Okay, so this is a trick that sometimes you have to do, not frequently, but just be aware, just be aware of that. And um, this is again how you can force it to return both of the solutions at the same time. One other thing just to mention as well, you can use this. It doesn't have to be for quadratics. The examples I did are quadratics, but you can use you could do it for absolute value equations as well. So like for example, here's an absolute value equation. Again, you could say like probably this is the left side and maybe this is the right side. So now I do like left side minus the right side. Here you don't have to worry about any of the constraints or anything, but notice it gives me the two answers. And of course you can just notice this one's 2/3, this one is 8/3, and so on and so forth. So there's your two there's your two solutions, your two roots, whatever. So it doesn't have the point is it doesn't have to be only for quadratic functions. Quadratic equations. All right, let's go back to the guide. Let's look at some factoring. All right, so the first thing I want to talk about is finding if an expression is a factor of another expression. So basically what you're going to do for this is you are going to graph the original expression. Then you're going to graph each possible factor. You're going to add sliders as needed if there are constants in either the answers or the original expression. And then you're going to look for the original expression and the factor to intersect or basically go through the same x-intercept value. Okay, so they will both have the same x-intercept value if the answer choice is a factor. Now, a couple things to be aware of. If the expressions have both an x and y in them, then sometimes they won't graph, and what you're going to need to do is you're going to need to type out the expression and then just put equals a number at the end of it. I just typically use equals 0, but you don't have to do that. You could use other numbers as well. You can also switch out letters for x and or y as needed to graph the function, meaning you replace them with a letter and then add a slider for that. Again, if there's constants in either the expressions, answer choices, or the original, then you can add sliders for them based on the conditions of the problem, like what they tell you. And one thing to keep in mind is um, some of these problems may not have x-intercepts. However, I think that's what I found initially based on certain factors, like if you're going to graph them out. However, there is a workaround to this, which I will update and add to the notes, and it's generally to make the slider values, if there are slider values, negative. Okay, so let's look at some examples now. All right, so the first one we have here, it's problem number 68. Here's the original expression. Okay, so I'm just going to, first thing we're going to do is we're going to type that in. Okay, notice nothing is graphing. It's giving me this error here. Try an equal sign. Okay, so equals 0. I'll do that. Perfect. All right, now, which of the following is a factor of this expression? So what I'm going to do is I'm going to type each of these. Again, they're not going to graph. You're going to have to do equals 0. Then what we're going to look for is which of these has the same x-intercept, i.e. crosses the x-axis at the same point that the original function does. So let's just get rid of these, look at them one at a time. Okay. Notice the x-intercept, the only x-intercept value here is at 4. This blue one's not going through it, so that's out. Next one. This one, I don't even see it anywhere on here. Am I missing something? Oh, never mind. There it is. Technically, it's overlapping it. For some reason, it wasn't shown on the screen. So this one appears to be the correct answer. All right, but let's just check the others just to confirm. Okay, this one, no, it's not going through +4. And the last one, nope, this line's not going through it either. So the correct answer for this one is going to be letter B. It's y minus 7x plus 28. Before I look at the next problem, I just want to go through another example briefly. It's not going to be found in part of the guide because it's in one of my monthly official problem test worksheets, but I want to kind of demonstrate what I had mentioned back when I was first talking about this specific type of operation about sometimes the factor, like none of the factors, intersecting at the x-intercept value and needing to make the, value of a constant negative. All right, so the problem I'm going to be looking at, this is from my August 2025 uh, official test problem set, worksheet number 3, and it's problem number 10 on this worksheet. Okay, so if you notice here, I'm not going to bother going through and solving this entire problem. I will just basically, tell you that if we go ahead and graph the original, because this is not what I want to highlight. So if we graph the original here, I already know what the correct answer is. It's going to be letter A. So notice here, if you add a slider, okay, right away A is 1. Notice they're intersecting at the same point. And you could check the other 3 and see that they do not intersect at the same x-intercept values, okay? Notice I slide this, wherever I go, notice they're still intersecting. Now, once you get above a certain value, they are not intersecting anymore, right up into about 3, but just you start off at 1, they're intersecting, it's the correct answer. Okay, so here's the thing. This function, if you go ahead and actually factor it manually, it basically turns into x plus 3a squared minus 81, and then it becomes x plus 3a plus 9, x plus 3a minus 9. Okay, if your difference of squares factoring, first you do the trinomial by grouping the first 3. If you don't understand it or follow it, that's fine. Go back, watch the full solution again from August 2025, worksheet number 3, problem number 10. All right, now the reason I'm bringing this up is, let's say you had this problem and the answer choices were identical, except I make this a plus. Okay, so in other words, 3 of the 4 answer choices are the same, except the first one now has the plus 9. Okay, so notice when you do this, okay, they are not intersecting at the same x-intercept value. All right, basically the blue expression, the factor, potential factor, doesn't have any x-intercepts. And my point was that if you try to make the a value, increase it to larger positive numbers, notice it never gets x-intercepts. Like, that's basically the point. Okay, and you can see the red one, essentially, yeah, it's like disappearing off the screen here as I make a larger and larger and larger. Notice it's like, yeah, going way up there. All right, so now the solution to this, say, type of problem is you have to make the a value negative. So notice what happens. We'll go back here to the regular screen. Okay, so I go back here to 1 where I started, right? If you make the a value negative, then eventually it will, basically that blue graph, the possible factor, will come down, and now you will see that intersecting the original expression at an x-intercept value, which confirms that it's a factor. Okay, and you can make this more negative, and you see they're both spreading out. But the point is, this is how you can confirm that yes, a would be a factor. And just to show you that the other ones are not factors here, I mean, you could already test them with the positive values, but here, negative value, see it's way up here, not a factor. Again, this one does briefly intersect it, but notice it's at a equals 0. Okay, so I'm guessing that in an official problem like this, it would technically actually have to say, like, where a is a non-zero constant or something, or something like that. So as long as a is not 0, as long as it's some non-zero number, the second one is never intersecting the original expression on the x-axis. And then if we did 3a minus 9, well, that's just a value. That's not, you know what I mean? That's not anything that is going to graph out or intersect it. And then if we did the last one, notice this one again, it's the same. So if you're in the positive values, right, it's not intersecting it anywhere on the x-axis. And even as you go into the negative values, notice here these blue x-intercepts are always between like the two red x-intercepts on either side of it. So therefore, it'll never intersect on the x-axis. Therefore, this just confirms D is not a factor. So I just wanted to highlight this to show you, this one example where with the slider value for if there's a constant in the expression, you might have to, depending on the potential factors you're given, you might have to make it negative instead of just choosing a positive value and then seeing it intersect, right away, which is what would happen for the original, A value, original answer choice for A from this specific problem. Okay, let's look at the one at the bottom now. And let me just zoom out so you can see. Okay, so you can see the whole problem. Again, you may recognize this problem. There is a similar one that appears on one of the Blue Book practice tests. Again, I won't say which, problem or whatever, not to spoil it for anyone, but there are, and I will also just mention, there are many methods that you can use to solve this problem. But this is just showing you how you can use, basically this idea of something being a factor of something else to find which one, to find what the answer is. So first we're going to graph the original expressions. This is the one that we're checking on being a factor. Then we are going to graph the various answer choices, which these are the larger expressions that it would be a factor of. Okay, so notice nothing here is technically graphed until I add the slider for B. All right, so what I am looking for is, as I move the slider, and notice B has to be an integer, so positive integers. I'm going to start it at 1, and I'm going to set the step value to 1. What I'm looking for is the red line intersecting one of these 4 other graphs on the x-axis at the same point. So like right now, okay, this one's intersecting here at -2, but none of the other ones are. So then I would go to 2, and I have nothing. Then I would go to 3, and I still have nothing. Then I would go to 4, nothing. 5, still nothing. 6, notice right here, I see the red one intersecting the purple one. So this is going to be our correct answer. Right here, it's letter C, 3x squared plus 43x plus 14b. And again, the way I confirmed that x plus 2b is a factor of this is I graphed the x plus 2b, which is just a line. I graphed, these various answer choices. I added a slider for b, but then I had to move the slider until the line and one of these answer choices intersected at the same point, specifically the same x-intercept. And just to show you, if you continue, it's not going to intersect the black one either. Like, if you zoom in here, okay, notice this one's already moved over to -16, but like, this black thing has moved over. It's crossing at -15.6. So you can keep going, but it's like the red line's going to keep moving, left, so to speak, for x-intercept, and the other ones are going to keep moving right. So that just confirms that the black one it's not going to intersect that. It's, it's letter C here. All right. So now let's talk about the bottom of the sheet, or basically just factoring in general, and some of the techniques that you can use to factor expressions. So in one of my earlier videos, I went through and said, the basic general way you can factor something is you can just, graph it out, and then obviously you can take your x-intercepts here, and, it's basically going to be like x minus each intercept value. So like x minus -1, x plus 5. Not 5, sorry. 0.5. Is that not what I have here? Sorry, x minus 0.5, x minus -1, except this is not quite matching because you have to multiply this by 2 to make this there. And now they match. Okay, you got to basically get rid of the fractions, the decimals in the factors. Okay, anyways, that's kind of like whatever. That's the technique I talked about way back, in the beginning of the series. Okay, these are going to go through now some more advanced techniques, show you how to do it for more advanced problems. All right, there's going to be two methods. I'll show you how to do both of them. The first one, you're just going to take your original expression, and then you're going to use regression. You're going to, tilde it to the factored form of the expression, and you can see that here. The factored form in general is going to be like, ax1 plus b times cx1 plus d. That's for a quadratic. And then maybe there's a k, like a common factor out front, or maybe not. That's method one, and I'll come back to that in a second. Method 2 is essentially setting up a system of equations where, I'm just going to draw on the screen to help demonstrate this. If you think about this ax1 plus b times cx1 plus d, if you think about those parentheses, right, and you FOIL it out, first, outer, inner, last. So it's like the first two things multiplied here, a times c, those have to equal the a value, or 8. For example, like down here, a times c has to equal 8. And then the last two terms, b times d, b times d, they have to equal the last number, the 9. And then the inner and outer terms, which are going to be like ad for the outer and bc for the inner, those added together have to equal the 22. That's essentially like how this works. You know what I mean? If you FOIL it out. So you set this up, essentially it's a system of 3 different equations, and then it will find values for A, B, C, and D. Now, here are the things to be aware of. So generally when you want to factor, you want the constants to be integers. That's how you're normally taught to factor. However, Desmos is just going to return any whatever random values, most likely decimals. And the way you avoid this, the way you fix this is you pick a value for a to start with, and then you move the slider through the possible values of a. When I say that, I mean the coefficient on, say, the x squared term. And you do that to then go see which value of a makes the other 3 constants, like the b, the c, and the d, all integers. Okay? This applies to both methods. So, and we'll go through examples. Most likely, if you just typed, this here right into Desmos, you're not going to get integers. I mean, k is just 1 in this case, but you're not going to get integers for a and b and c and d. All right? You're going to have to start with a equals 1, and then you're going to have to go through the other possible factors of 8, okay? Because a here is a possible factor of 8. So you check 1, and then maybe 2, and then 4, and then 8. And one of them is going to give you all integer values for a, b, c, and d. So that's essentially what I'm talking about. And it's the same thing down here if you use this approach. Now, there is another thing to mention too. You might not need to do this if some of the coefficients are already given in the way that it's factored, then you might not need to do this type. You might not need to use sliders. Like it might just find the factoring right away, and therefore you're set, and you don't need to go through that. So just be aware. Just be aware of that. The other thing is too, if there's going to be a GCF for sure, then you can just use the GCF function. So GCF, and then put in whatever the values are. In this case, it'd be like 8, 22, and 9. 8, 22, 9. And that's going to just return 1. But that would find the GCF to factor out, and you could put that in front out here, in terms of k. And then the last thing we'll look at an example with this, but there's one specific type of problem that they've had where they want you to factor an expression two different ways. The first way is using all integer values. Okay, so you factor it, you get the normal standard factorization, you get the values for say like a and b. Then the second way is you factor it, but they want specifically non-integer values. They want decimals. The way that you do this type of problem, the way that you can do it is you basically do method 1, except you can switch like the two parentheses. So in other words, these are like separate entries in Desmos. Like one of these is on line 1, one of these is on line 2. So notice I switched the parentheses. So like in the first one it's 4x1 and 2x1 second, and the second one is 2x1 first, 4x1 second. And when you do that, for some reason Desmos will give you the second like solution, or the non-integer values like for C and D. So we'll look at an example problem of that just to kind of to demonstrate that. And one last thing, if I forgot to mention this, you definitely do need to do, for the first method, the element list of where you need to add x1 equals and then some values, and I usually do like a negative, 0, and a positive, and then some other positive values, but you do need to add the element list here after your regression statement, again, for it to work properly as well. All right, so let's now go back to the guide and look at some problems. Okay, this first problem here, we are given a cubic function, and it says it can be factored into multiple factors of x plus b, where b is a positive integer constant. What is the smallest value of b? Okay, so for this one, I am going to use method 1. So first thing, type in my original expression, right? Next, I need to see if there's a common factor to pull out. So let's do the GCF of 2, 102, and 196. All right, it looks like there is. So I'm going to pull the 2, the common factor, out front here. Now, everything else, there's going to be, like, basically there's going to be 3 other factors, because these are equal to, this is a cubic polynomial. There should be 3 roots. So I'm going to use, let's say, A, B, and C to represent my 3 roots. Notice it's not working properly right now because it has x1 just as 1, and that's not correct. I want x1 to be treated as a variable. So now when I add in the element list, notice it now gives me the correct factorization. Basically, the factorization is just going to be 2 and then times x plus 0 times x plus 49 times x plus 2. Now, normally x plus 0 you would just make x, and then like this 2 and the x would be combined. So essentially it would really, really the way you would normally see it factored is like this. But just to confirm that I have the correct factorization, notice that these overlap completely. Okay? So now, what's the smallest value of b? And I'm also just going to go back to just how it was written originally. Again, you don't have to type this out like I'm doing. I'm just doing this to help visualize what the answer is. So, what's the smallest value of b? Well, b is a positive integer, so it has to be 2. All right, and that's it. It's not 0. 0 is not positive, and obviously 2 is smaller than 49. So the correct answer to this question would just be positive 2. All right, let's look at another problem now. And this next one, I'm going to show you using both methods. So we're given this original expression, and we're told it can be factored in the form 20 times a, parentheses, x plus squared plus b, cx squared plus c, blah, blah, blah. What's the value of a plus b? Okay, a times b plus c. All right, so here is method 1. Typing the left side. Now, I don't know. First, I'm going to try and see if it'll find A without me needing to find the GCF, because it might not actually be, in this case, it might not be the GCF that we factor out. So I'm going to try doing it like just doing it exactly as it's given and seeing what happens. Okay, perfect. So it looks like everything worked out perfectly. Um, and so A times B plus C is just equal to 40, and there's our answer. Okay, so it gave us A, it gave us B, it gave us C, and that's it. And and there's our answer. Now, just to confirm, here is the original. I'll zoom out in a second. We can see this. And then just to carry the values over, cx plus, oh no, sorry, these need to be squared. 8. Okay, so let's zoom out. Okay, way up here, it's real narrow. Okay, but hopefully you can see, let's see if I can there, it's a little easier to see now. Hopefully you can see that this is the original. This is the factored form based on, A, B, and C from regression, and notice they overlap, meaning they are identical, i.e. it is factored correctly, you know. Therefore, the correct answer for this, again, is just 40. All right, now, let's say we want to do it using the second method. Okay, so let's get rid of this. All right, here's what we have. And this one is going to be a little bit trickier because of the common factor, the A that's pulled out front. All right, so to use this method, technically what I'm going to have to do is I'm going to have to multiply this A through just to turn it in the first parenthesis into this. And now what I'm going to do is I'm going to note that, okay, my first two terms, which are AC, are equal to 20. And then my inner and outer terms, so my outer term is 8 times A, my inner term is actually ABC. Those two added together are equal to 120. And then the last two terms, which will be 160, is 8 times AB. Notice what happens here is it actually gives me different values for A, B, and C. However, the A times B plus C value is still the same. Okay, so now for the next question, number 72. This is going to be one of those where you're going to have to use a slider for one of the constants, specifically A. All right, so this one I'm probably just going to demonstrate using method 1. So you're going to type the original expression and tilde. Now technically there's no common factor here. Now I can just tell that by looking at it, but if you weren't sure, you could type all three and notice the GCF here is just 1, so you don't have to worry about putting anything out front. And then I've got ax1 squared plus b and cx1 squared plus d. Okay, now I have to add my element list for x1. Notice, even if I continue to add more values, it's just giving me random decimal values here, okay, which is not what I want. I want integer values. So the workaround to this is we're going to take A, and we're going to start with it equal to 1. Basically, I need to set it equal to factors of 8. That's what I'm going to check. And so when I do 1, notice the other values are not all integers. Therefore, I'm going to check 2. Okay, so notice when I do this, the other factors, again, are not all integers. Okay, so now I'm going to check 4, the next factor of 8. Now they are all integers, so that means it looks like I have the correct factorization, which is going to be 4x squared plus, not plus, plus 3 times 2x squared plus 5. Now let's just type the original and confirm that this matches. And it does. Notice they overlap completely here. Okay, so this is the correct factorization. So now you're probably saying, all right, well, what's AB? So AB is 12. All right, look at the answer choices. Not an answer choice. What's going on here? So basically what's happening is the A and B technically represent either of the parentheses. Like it doesn't matter which parenthesis here I designate as like A x squared plus B and which one I designate as CX squared plus D. The A and the B could be from either parenthesis. So you technically, for a problem like this, you have to check either A, B, or CD. And when you check CD, you get 10, which is the correct answer. You know, letter C right here. Okay, so that's how you can solve number 72 entirely on its own. And actually, I said I was only going to show method 1, but I will just show you real quickly since we already know how to solve it. Since we already know how to solve it, basically, here's what method 2 would look like. Tilde this. Okay, so we know it's going to be 8, 26, and 15, right? And we know it's AC, AD plus BC, BD. Okay, again here, notice for this one, a equals 1 doesn't, not all integers. A equals 2, it actually is all integers. And notice in this case, the AB value actually does give me the 10, you know, which is one of the answer choices. CD is 12, which, so the values are just reversed, you know, for whatever reason when I chose to use this method. And this we don't even need anymore. That we can get rid of. Okay? So if you want to do it this way, again, that's totally fine, you know, using method 2, but you get the same correct answer of 10. All right, let's look at the last one. This will show you the technique of basically like flipping the parentheses. So what I'm going to do here is I am going to type the original expression like this. And now, forgot my tilde, add my element list. Okay. So notice right here, it's finding the two integer values. You know, it's like 3x plus 5, 2x plus 3. That's how it factors, okay? Now, I'm going to copy this. And what I'm going to do is I'm going to switch these, meaning I'm going to make this a 2 and this a 3. But notice here, for the second one, I have to change this to a C. The C corresponds with the 3, and that goes in the second bracket. And the D corresponds with the 2, not bracket, parenthesis, goes in the first parenthesis. So now it gave me like the second factorization, the one where the two constants are not integers. So now what's A plus C? Right here it is 9.5, or, I mean, you just type it if you want to convert to the fraction. It's 19 over 2. Not sure why the fraction thing doesn't show up here, but in any case, it's 19 over 2. Notice you can keep the same element list. You keep everything the same. I mean, you keep it x1 still. It's just for some reason when you switch the order of the parentheses, it will find like the second, you know, solution, the non-integer solution for you. Okay, so I hope you enjoyed this video. If you did, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. As I mentioned previously, again, these problems, there'll be links to them in the Desmos guide, both in the description and also in the pinned comment of the video. If you have any questions or comments about the problems or topics covered in here, please do leave them, you know, in the comment section below of this video. And obviously, if you haven't done so already, check out the rest of my Ultimate Desmos Guide to Digital SAT Math. It's now up to almost 7 hours of tips and tricks and 73 total practice problems to help you ace the digital SAT math section.